Welcome you all guys to Debugging Doubts. In today's topic, let us study about RS latch using NOR gate. In the previous video, I have made using NAND gate. If you haven't watched my video, then please click the link here and watch it. First, let us study about important properties of the NOR gate. If you haven't seen the universal gate video, then you can click on the link above and watch it. If either value of the input of the NOR gate is 1 or 0, what corresponding output are we getting? So let us understand it. Okay. In the second input, I'll take it as x. X may be 0 or 1. So when the input value is 1, what the NOR gate will do? It will basically add the inputs 1 plus x and negate it whole bar. That's equal to 1 plus x is 1. So in the properties video I have shown, right? So 1 plus anything is 1. Then whole bar. That's equal to 0. So output will be 0. So whenever any one of the input of the NOR gate is 1, then output is compulsorily 0. That thing you must remember. Now let us understand what will happen if the value is 0. What the NOR gate will do? 0 plus x and whole bar is equal to 0 plus x is x itself using property. Then whole bar, that's equal to x bar. So output is x bar. Here the output value will depend on the x value. That is, if x is 0, then output will be 1, and if x is 1, then output will be 0. Now the same statement is given here. If one of the input of the NOR gate is 1, then the output is 0 only. Please try to remember this statement. Now coming on to the RS latch using NOR gate. Now first I'll consider 0 and 1 value. Okay. R value is 0 and S value is 1. What will happen? You can see it, right? If S is 1, the output is surely 0. And this 0 will go as input to this first NOR gate. So this 0. So 0 plus 0 whole bar. So this NOR gate will give output as 1. Now this one will go here. So 1 plus 1 whole bar is equal to 1 bar is equal to 0. Once again we got 0. You can see we got the same output. RS latch is balanced. So I will write the output here. So Q is 1 and Q bar is 0. Now let us consider the second one. That is when R is 1 and S is 0. What will happen? So R is 1, right? So our output is obviously 0. Then this 0 will come here and 0 plus 0 whole bar is equal to 0 bar is equal to 1. So this Q bar is 1. Now this will come here. Then 1 plus 1 whole bar is equal to 1 bar is equal to 0. Once again we got the same value, that is 0 0. So now the RS latch is balanced. So we'll write the output, that is Q is 0 and Q bar is 1. Okay. Now we'll consider 0 and 0 case. When R value is 0 and S value is 0. You know that if either input is 1, then output is surely 0. But if both R and S are having 0 values, let us consider that for first gate, the Q bar value will come as the input. 0 plus Q bar whole bar is equal to Q bar double bar, okay, is equal to Q itself. Now we got the Q value. Now this Q value will come here. So what will happen? 0 plus Q whole bar is equal to Q bar is equal to Q bar itself. Now this Q bar will once again go to the first gate. Now the output is balanced, right? Same the Q bar is going on. So from Q we got Q itself, and from Q bar we got Q bar itself. So what we observe here? Same output as the previous. So I will write, when we have 0 and 0 combination, output is same or hold. Okay. Now we'll consider 1 and 1. R is 1 and S is 1. What will be the case? You know that when one of the input is 1, then output is surely 0. But here you can see both are having 1. Okay, so we'll consider from first gate. Okay, you can consider any gate. You can choose first gate and try, and second gate also you can try and solve it. Same answer will get. So I will consider by first gate. Okay, so when one of the input is 1, the output is 0. and this 0 will come here, and 0 plus 1 whole bar is equal to 1 bar, that is 0. So this 0 will go here, and the same thing, 1 plus 0 whole bar is equal to 1 bar is equal to 0. Now if you try to observe, q is equal to q bar is equal to 0, which is violating the property that the same value and negated value cannot be equal. But here both are equal, so you can't consider this input. So I will write it here as invalid. Okay. So this is how you can try to represent the truth table. And if you observe my previous latch video, in 1 and 1 it had same, and in 0 and 0 it had invalid. That's why I'm saying if you know the logic, then you will write the truth table in correct manner. So better you try to understand the logic of both the latches. Then the flip-flop is easier for you all. This table you can refer. And thank you all for watching my video. In further coming videos, let us understand about flip-flops. And if you like my video, please like it and share it and subscribe it. Thank you all for watching.